Business Calculus, Topic 6.2. We're finding the area enclosed by the function e to the negative x, the function 3, and the y-axis. Okay, so let's kind of draw that up. E to the negative x is a curve that is rapid to slow decay. And it goes through 0, 1. And it's also asymptotic to y equals 0. F equals 3 is a horizontal line. Looks like this. And the y-axis is here, which is essentially x equals 0. So we're looking for the area that's within here. Okay, let's pin down our x's. This x right here is 0. This right here we don't know yet, so we'll find that because we need a area to integrate by. So to find this intersection here, we're going to use a couple methods. We're going to use the graphing calculator method first, and let's go to y equals, and let's clear all that out, and let's type in e. Let's see, my function e, second function e, and that's going to be to the negative x, so negative x. And let's go down and type 3 for the next function, 3. And let's zoom standard 6, so we'll get a nice 10 by 10 graph. And you notice all the action is kind of happening in here. I'm going to blow that up a little bit. So zoom in, so number 2. And a little too much because 3 is way up there, we can't even see it. So I'm going to expand my y's a little bit. So a little window, and let's put in y's are about, let's say, -5 and +5. Okay, and we'll graph again. Okay, great. And we see the intersection right there. That's what we're going for. So to find that, we're going to go to second function, calculate, and intersection is number 5, enter. And first curve, that's what we want. Second curve, that is what we want. Guess, okay, let's move our graph over, our little star here, cursor, over to this intersection right there, and press enter. And we get an intersection of -1.0986. Okay, -1.0. Running out of room, so I'll put 1.1. But when I calculate this, I'm going to use -1.098612. I want to use more numbers, but right here for now, I'll put -1.1. Okay, that's our intersection. So to find the area between two curves, it'll be the limit from -1.1 to 0 of the upper function right here, which is 3, minus the lower function, which is e to the negative x power, and that's the x. Okay, switch pins here. Alright, the antiderivative of 3 will be 3x. The antiderivative of e to the negative x is double negatives, which is positive e to the negative x. And this will be evaluated from -1.1 to 0. So everywhere we see an x, we're going to put the 0 here and here. So that'll create 0 here, gives me 3 times 0 is 0. And e to the 0, that's 1. Okay, so it's 0 plus 1. Now when I put the all these decimals here for x, let's do that this way. Let's go back to the original screen, and let's say that -1.098612. Let's store that into C, so alpha C. So anytime I do type of alpha C, I can get that number back. Alright, so we want to multiply 3 times that C. In fact, let me store that into X. So let me store that into X instead. So I want a 3 times x. So 3x, and then I want plus e. Let's see, where's my e? E raised to the negative x. Okay, and now it's going to put that number in there for x on both places. And so I get a negative 2.958. Okay, and I have double negatives, that's going to be a positive, so it's going to end up being a 3.958 for the area. You read that 8 there. Alright, next. We want to find the area enclosed from day 0 to day 3. And my income is described as this function right here, $50,000 plus $2,000 per year. And my expenses are described as $45,000 plus $1,500 per year. And the area between those two curves. Well, if I were to kind of draw these two curves, my income has a starting point of about $50,000, and it increases by $2,000 every single year. So it's going up. So that's my income. My expenses start at about $45,000, it's a little lower, and they go up every year by about $1,500. Okay, so there they go. Alright, now we want the area between day 0 and day 3. Or sorry, I think this should be year. But day 0 is here, and day 3 is there. It really should be year. Year 0 and year 3. And I want the area right in there. Okay, so that means I have to take integral from 0 to 3 of the function, the upper function, which is 50,000 plus 2,000t, and I'll need to subtract the lower function, which is 45,000 plus 1,500t. Okay, let's put all that in bracket, and dt. Alright, now let's begin to subtract these. We'll get 50,000 here and 2,000t there. Change the signs here, we get negative 45,000 and a minus 15,000t. And let's see, we combine these two, we'll get 5,000, and we combine these two. Let's see, am I leaving out something? 2,000, this is 1,500, too many zeros there. Something was wrong. We get plus 500t dt. Alright, the antiderivative of 5,000 is 5,000t. The antiderivative of 500 t will be 500t squared times 1/2, and evaluate it from 0 to 3. Okay, this ends up just being 5,000t. Half of 500 is 250t squared, and we'll put 0 and 3 in there. Okay, when I put 3 in here, this becomes 15 with 3 zeros. And if I put 3 here, I get a 9 times my 250. 9 times 250 is 225 with a 0. And, okay, that'll be that answer, minus the other answer. When I put 0 in both of these t's, all that becomes 0. Alright, so it's just a matter of adding these two up. So this will be 175. Wait, I got that wrong. This will be 17250. Okay. Now, what is this interpreted as? Well, since this is all the differences between my income and my expenses, this is basically all the money that I have left, or this is my disposable income, as you would call it.